start. In this, I'm briefing you about the module 3. Okay, what is module 3? That is basically this one, lecture 21, lecture 22, and star delta 23 and 24. If you are from BT background, then 10 marks from these topics will covered. Okay, so these will include only 3 topics. One is the balanced, another one is the unbalanced, another one topic is the power measurement, right? So for the balanced, we'll have balanced star and we'll have balanced delta. In case of balanced star, current is equal, so line current would be equal to phase current, and line voltage must be equals to the √3 times of phase voltage. But in case of delta balance, we'll have formula VL is equals to VPH and IL is equals to √3 IPH, right? Now after that, we'll have unbalanced system. In unbalanced, what is the difference between basically the balanced and the unbalanced? That is, in balanced, all the impedance are equal, right? All the impedance are equal, but in case of unbalanced, all impedances are unequal. Okay, so we'll have some different values for ZR, ZY and ZB. For the unbalanced also, we'll have star connection and we'll have delta connection. Okay, so in the star connection, for unbalanced I'm particularly talking about, we'll have voltage is different, so VRY would be equals to VRN minus VYN. Similarly, VYB is equals to VYN minus VBN, and VBR is equals to VBN minus VRN. You don't need to learn these formulas because these formulas are mentioned in your handbook. Okay, now next one is the delta connection. In the delta connection, we'll have current is different, so IR is equals to IRY minus IBR. How will we move? We'll move according to the RYB series. See, basically, if you know about it, we'll have 2 sequence. One sequence is known as positive sequence, another sequence is known as negative sequence. Okay, positive sequence is RYB, negative sequence is RBY. Okay, so generally if they didn't mention, we'll consider positive sequence only, or they'll mention, then we have to take it according to this sequence. And sometimes they'll mention instead of RYB, they can mention ABC also. So IR is equals to R के बाद क्या आ रहा है Y, then B के बाद R. Similarly, IY is equals to YB and then IRY, and IB is how much? IBR minus IYB. Clear? And now we'll have the power measurement. So see what happens in the power measurement. Basically, we'll use these formulas. We'll need to calculate maybe the total power that would be measured by wattmeter method. As you know, what is wattmeter? Wattmeter is a device which is used to measure the power, correct? So power, we'll use 2 wattmeter for the measurement of power. Here W1 value is VL, IL cos of 30 plus 5, and W2 value is VL, IL cos of 30 minus 5. And if they ask you to calculate power factor, then power factor is cos of tan inverse √3 W2 minus W1 divided by W2 plus W1. Again, these formulas are also mentioned in your handbook. Okay, so basically this one balanced, unbalanced and power measurement. Now we are left with the power. Like, we'll have 3 kinds of power. One is the active power, right? another one is the reactive power, and another one is the apparent power. Active power formula for the single phase, it's VI cos phi, right? But now we are learning the three phase, so it would be √3 VLIL cos phi, or if we want to calculate in terms of phase, so it would be 3 VPH IPH cos phi. Reactive power would be VI sin phi, so it would be √3 VLIL sin phi, or 3 VPH IPH sin phi. Apparent power would be for the single phase VI, so for the three phase √3 VLIL 3 VPH into IPH. What is the unit of active power? That is what? Unit of reactive power VAR, unit of apparent power VA. Okay, now see, in this they said three similar coils, okay, each resistance 7 ohm, so, and inductance means R is 7 ohm and L is 0.03 Henry, and they said they are connected in delta. So in the delta, line voltage is equals to phase voltage, but the current is I is equals to IPH, and they have mentioned voltage, that is VL. If they didn't mention any voltage, then that voltage is always the line voltage. Frequency is how much? 50 Hz, and they have mentioned that they are using RYB sequence. Assuming VRY as the reference, calculate the line current. Okay, this is of 6 marks question. So as you know, formula according to Ohm's law, we'll have VPH is equals to IPH multiplied by ZPH, right? Now try to solve it further. Right, see, this is the formula, VPH is equals to IPH into ZPH. We never use this formula, VL is equals to IL into ZL, because ZL is never in phase. Sorry, ZL is never in line. Z is always in phase. Okay, because as if I'll draw the diagram, this is the star, R and L, R, L, R and L, right? So Z is always in phase. This is R, Y, B. So for that you need to calculate. ZPH formula is R plus 3XL, right? R is how much? 7 ohm plus J. XL you need to get it. 2 pi FL, right? So calculate the value for ZPH. So after solving ZPH, you can substitute it here. VL is 400 only because it's a delta connection. We can get IPH. Then they are asking active power, reactive power and apparent power. So for that you need cos phi, and whatever the angle of impedance you are getting, that is phi only, right? Like suppose after solving you are getting 85.75 angle of impedance, so that is phi. You can get cos phi easily and you can get sin phi easily, right? So you'll be able to use active power, reactive power and apparent power formula. Got it? See, in this question they said the phase of a lightly loaded voltage V is 450 volt, delta connected, delta means VL is equals to VPH, draws a current, IL is equals to 13.86 and power factor cos phi is 0.47. The 2 wattmeter method is used, so they are asking W1 value and W2. So for that you will have the formula W1 is VL cos of 30 plus phi. So you are having VL also, IL also, and from here you can get the value for phi, that is cos inverse 0.47. Similarly, you can get W2. Determine the active and reactive power using wattmeter readings. Okay. So you can get active power. This is total P, W1 plus W2. You can get active power, right? After this they have mentioned now you have to use wattmeter reading. So this is P, cos phi is given 0.47. Can we get S? And can we get Q from this power triangle? Yes or no? See, now this is unbalanced, and generally unbalanced comes for 6 marks in B. Okay, so they have mentioned Z or Y is equal to 50 plus J40, ZYB is equals to 100 ohm, and ZPR is equals to 80 minus J60, and VL is equals to VPH, that is equals to 415. But for case of unbalanced, we have to consider angle also. So first angle VRY, as they have mentioned the RYB sequence, so it would be 415 angle 0. Then RY, Y के बाद B, so VYB is how much? 415 angle minus 120 degree. VBR is how much? 415 angle minus 240 degree. Okay, these are fixed. RY का angle is 0, YB का angle is minus 120, and BR का angle is minus 240. See how it comes? Like suppose this is RYB. So you can see RY का angle difference is 120, right? Because this is complete 360. So 360 divided by 3 is 120. So in each to minus 120. And the angle difference between R and B would be minus 240. Okay. So don't go so much into deep. You just need to learn that these are the fixed angles. So according to Ohm's law, IPH is equals to VPH by ZPH. VPH means like IRY would be equals to VRY by VRY is known 415 angle 0 degree. ZRY is 50 plus J40, right? IYB is equals to 415 angle minus 120 degree, and ZYB is 100. IBR is how much? 415 angle minus 240 degree, and that is 80 minus J60. Now solve it, and then you will get the IRY, IYB and IBR. Now these are the line currents or the phase currents? These are the phase currents, and we need to calculate line current also. So remember the formula which I told you? Yeah, basically these are the line current and these are the phase current. Correct? So from these you can get phase current and you can get line current. Now they are asking the phasor sum of line current. Phasor sum of line current means IR plus IY plus IB. Ideally it should be equals to 0. Okay, but the formula is IR plus IY plus IB is equals to IN. If there is some leakage current, then that would be the current flowing through the neutral. Okay, clear? So see, in this they said a three-phase star connected load. Whatever they have given, write it down. Star means line current is equals to phase current, and VL is equals to √3 VPH, right? And then if the load is connected to this and VL is given 208 volt, wattmeter, we have to calculate the wattmeter readings, means we need to calculate W1, W2 cos phi, right? But for Z is given 8 plus J6. So from here we can get phi, right? And as you know, formula VPH is equals to IPH into ZPH. VL is this one, VPH is how much? 208 by √3, right? IPH will remain IPH only. ZPH is 8 plus J6. We can get IPH from here. Then we'll apply VL, IL cos of 30 minus phi, 30 plus phi, and we can get W1 and W2. After getting the value for W1 and W2, we can get we can get P. We can get cos phi. Okay, and after getting cos phi, we can get active power, reactive power, and apparent power. You just need to put it down the formulas, right? Clear? Okay, now see, this is the question of star unbalanced. So always remember, or you can mark it, that in case of star unbalanced, we have to use mesh analysis, or we can use Cramer rule. Okay, means that is different from these questions. See, they said ZR value, ZY value, and ZB value. So for that you need to draw the diagram. Maybe the diagram is given, maybe the diagram is not given. So draw a star connection. This is ZR, this is ZY, this is ZB. Current across ZR would be IR, this one would be IY, this one would be IB. Voltage across R and Y would be VRY. Voltage across Y and B would be VYB. Let us consider here I1 current is flowing and here I2 current is flowing. Okay, clear? Now see what we'll do. We'll apply mesh for the first mesh. That would be like, if I'll mark the sign positive, negative, positive, negative. So minus ZR into I1. We have to consider mesh analysis by our own current. Okay, minus ZR I1 minus ZY I1 minus I2. Then plus VRY is equals to 0. Right? Yes or no? Okay. After this, we need to get current for the second mesh, minus ZB I2 minus ZY I2 minus I1 plus VYB is equals to 0. Correct? Do you know about the mesh analysis? Plus minus plus minus. See, we have to mark sign according to the current movement. I2 is moving plus minus and then plus minus. And for the mesh analysis, we have to take the second sign. If you are moving the mesh like this, second sign we have to take. So it would be minus ZB I2 plus YYB and minus ZY I2 minus I1. Okay? Clear? After this, as you can see the question, voltage is given, that is 400 volt. This is the line voltage. So we are Y 400 angle 0. Second, I told you that is minus 120. Third one, you can take it 400 angle minus 240 or plus 120. That's one and the same thing, right? After this, we can substitute the value of VRY and VYB, ZR and ZY. Yes, can we convert it into matrix form? I1, I2, and that goes to the right hand side. Voltage I'm taking on the right hand side. 400 angle 0, 400 angle minus 120. Solve it and tell me the coefficients of these. See, after solving, you will get is 10 angle 0 plus 15 angle minus 30. Then we'll have minus 15 angle minus 30. And here it would be minus 15 angle minus 30. And here it would be 15 angle minus 30 plus 20 angle 45. So after solving, we will get I1 is equals to 9.7 angle minus 17.87 and I2 is equals to 16.69 angle 1 minus 116.63. So basically we are getting the line currents, right? But they don't want us to calculate I1 and I2. They want us to calculate IR, IY and IB. Yes. So as you can see that IR and I1 is in the same direction. So can we say that IR would be equals to I1? Similarly, IB and I2, they are in the opposite direction. So can we say that IB would be equals to minus I2 and IY is equals to I2 minus I1? Yes or no? So now do you know how to do subtraction if you are having the currents in the polar form? Like you are having the currents in the polar form, na, IY would be equal to I2 minus I1. One option, you can convert it into the rectangular form, right? Another option, you can directly subtract it in remaining the polar form only. Do you know the method, that one? See, after solving, we can get line current, okay, and the phase current. So I'm telling you the value for the line current. IR is how much? 9.7 angle minus 17.87. IY is how much? That is I2 minus I1. So you will get to 20.59 angle minus 144.63. And IB is equals to minus of I2. So 116.69 angle 63.37. These are the line current as well as the phase current, right? So after this, we need to calculate. See, in the question they are asking phase voltage, correct? So according to the formula, VPH is equals to IPH multiplied by ZPH, right? VR phase है तो VRN would be equals to IR into ZRY, okay, or ZR, right? Because they have mentioned ZR, correct? So IR we know, we have calculated. ZR we know, that is 10 angle 0. Can we get VR? N. Similarly, can we get VYN? And similarly, can we get VBN? So after solving, we'll get VRN as 97.83 angle minus 7.87. And this one would be 308.85 angle minus 174.63. 338 angle 108.37. Okay, understood? And now they are asking the neutral shift voltage, right? So how will you get the neutral shift voltage? Basically, neutral shift voltage, that we have already calculated, right? So now sometime they'll ask you to draw the phasor diagram as well. So how will you draw the phasor diagram? Okay, I'm drawing. So we have to take the line voltage first. VRY, VYB and VBR. As I told you, the sequences are YB, right? R के बाद Y के बाद B and B के बाद R, right? So angle between these one is 120 degree, correct? So as you can see, the angle between line voltage and phase voltage is 30 degree always. So we can draw, this would be VYN, VBN, no sorry, VRN, क्योंकि VRY का component is VYN and VRN now extended. This will be minus VYN, one would be positive, one would be negative. So if I'll extend it, this would be plus VRN. Now VYB का एक component तो already आ गया, VYN, this would be VBN, this would be minus VBN. So this is how we can draw the phasor diagram.